In this video, we're going to talk about rational expressions, and we're going to look at multiplication and division of rational expressions. So rational expressions are expressions that have numerator and denominator, and they represent, so like if you have a polynomial in the numerator and denominator. So for example, this is a basic rational expression. Multiplication of it would mean I would take and then multiply across the numerators and say Q times R, and multiply across the denominators and say Q times S. Now there's stipulations that you cannot have 0 as the denominator, so Q and S could not be 0. So it's very similar to multiplication of when we do fractions. So if I had, let me start with some basic fractions. I had this. When I'm multiplying fractions, all I need to do is multiply across the numerators. 2 times 7 would be 14. And I multiply across the denominators. 5 times 9 would be 45. And as I'm multiplying, if I see anything that can factor out, I would factor it out. Or at the end, I can say, well, both 14 and 45 might have a common factor that I could divide out. In this case, there is nothing that would divide out of both of these. But let's look at one that would have something to divide out. So let's say we had this. Well, now when I look at this, I can see that both 15 and 10 have a common factor of 5. So I could divide that out of both of these. So if I divide out 10 divided by 5 is 2, and 15 divided by 5 is 3. And then I look and I see 8 and 16. So I'm looking at items that are one's in the numerator, one's in the denominator. 8 and 16 have a common factor of 8 that would divide out. So 8 divided by 8 is 1, and 16 divided by 8 is 2. And notice I'm writing the numbers there that are left so that I remember that those still are there available. Now, is it possible that there are more factors? Yes. So when I see this, I get 3 times 2, and I get 1 times 2, which is 2. Now this will simplify to 3. Both of these have a common factor of 2 that divide out. So I end up with 3 over 1, or just 3. We could have simplified it at this point too, or you could do the multiplication. But doing the multiplication by hand of 15 times 16 does get tedious, so it's best if you do it along the way so that you can simplify as you're going, because then it makes it a little bit easier in the end. But sometimes when you have the very large numbers, it's harder to see what factors divide out. So the same process that we're talking about here is what we use to multiply rational expressions. So let me put on the board a rational expression, and we'll see the same process is what we will do. So here, multiplying across the top, and then multiplying across the bottom. Now, do I see anything having a common factor that is in opposite locations? So one's in the numerator, one's in the denominator. I don't. So I have 21, 3 times 7, and I'll plug the numbers together. And then the variables x and z, they aren't like terms, so I can't combine them, but it's just x times z. And in the denominator, I have 4 times 10, which would give me 40. And then y would be left. So this would be this multiplication of these two rational expressions. So let's look at an example, another example. So let's say we have 7a over 3b times 15b over 21a cubed. So when I take a look at this, I do see the 3 and the 15. Those would have common factors of 3. So I'm going to say 3 divided by 3 is 1, 15 divided by 3 is 5. I see 7 and 21. Those have a common factor of 7. 21 divided by 7 is 3, and 7 divided by 7 is 1. I also see that I have a b up here and a b over here. So think about it. If you had b over b, this is what we talked about. That's what would happen at the end. If you had b over b, it would simplify to b to the first minus 1. These are both exponents of 1. We would rewrite the base and put the numerator exponent, subtract the denominator. I would end up with b to the 0, which we learned was 1. We have the same factor. B divided by b would be 1. So these would cancel out to 1. And then I have a. I have a up here, and I have a cubed down here. So it's a to the first over a cubed. So it would look like this. Let me just write it to the side. And it would be a to the first minus 3, or a to the negative second. So I could also look at this a different way, and I could say, well, I'm just going to write it over here. Looking at just this. This is a over a times a times a. So one of the a's would cancel out, and I would be left with 1 over a squared. So that is another way I can look at it. We know that a to the negative second in the numerator would move to the denominator and become 1 over a squared. We just don't want to miss this 1 over. It's always when, if you do it in this form, then you don't want to just write a squared because it's not. It's 1 over a squared. So I'm going to cancel this out, and this will make it a squared. And now let's write what's left. Well, we have 1 times 5, that's 5. The variables all canceled out, so just 5 in the numerator. And then I have 1 times 1 times 3, which is 3. And then I have a squared in the denominator. So this would be the simplest form. So this one here, now I've got these polynomials, so a little bit different than the previous one. So when you are approaching these type of problems, whether it is like the previous one or this, what you want to do is factor the numerator and denominator. And that's what we did. We kind of find those common factors. The same thing here. We're going to factor the numerator and denominators. So let me rewrite this. And I'm going to factor this first part here, 4x minus 8. I'm going to rewrite that. There's a greatest common factor of 2 that would factor out of both of those terms, and I would get 2 times x minus 4. Then the denominator here does not factor any further. There's no GCF. And the denominator over here doesn't factor any further. In here, in this one, we have an x that's in common in both terms. So I could factor the greatest common factor of x out. And then I'd be left with x plus 6. And then I see, oh wait, here I have x plus 6 in the numerator, and I have x plus 6 in the denominator. Those would divide out. Let's see what else I can divide out. I have a 2 here and a 2 here that would divide out. And then I have an x here and an x here that would divide out. Oh, I just noticed one thing. When I was doing this factoring, this should have been, I factored out a 4. Okay, so let me back this up a step. Sometimes you make an error and you can go back. Between these two, we have a 4 in common. I'm going to factor out a 4, and that would leave me with x minus 2. So I have an error there, so I'm redoing that part. Okay, so the 2 would divide out this. Both of these have a common factor of 2. I'd be left with 2 over 1. So now I see what is left. I have 2 times x minus 2. So this would be my answer. I can write it like this, or I could redistribute the 2 and write it like this. So either of these would be correct.